Hello everyone, I'm Thomas and this is day 8 of 100 Days of Code in IoT Challenge. For the past 3 days, I've been working on this project, which is simply a time-controlled relay with the buzzing buzzer as a notification. Today, I'm going to add some connectivity to this project. So along with the buzzing buzzer, we're going to have ESP8266 making a HTTP request and sending it first to the local server hosted on my computer, and then to a web service hosted on the internet. There's not really going to be any new parts or components, but we're going to start from the breadboard view because I'm going to have to move the buzzer on the board. So let's just quickly switch to that view.
The reason I need to move the buzzer is simply because it blocks the way of the USB cable, right? I cannot really connect it to USB port. And, I don't really want to disconnect and connect it multiple times whenever, I switch between the USB power or deploying the sketch and this power source. Alright, so let me just quickly move it. What I need to do is, I'm gonna start from moving this one somewhere here, let's say, at the very end of the board, and then essentially blue wire, which is D2, to the plus of the buzzer. There's row 60, and this one, which is the ground, is gonna go to the minus of the buzzer. Now, one additional step, since we're switching back to the USB power, we don't want 3v3 to be connected to the plus rail. So I'm disconnecting it. The ground is fine, but 3v3 needs to remain disconnected for now. Okay, now I can easily connect USB here. Okay, let's move to the code. Okay, here is the code from yesterday, but before we start modifying it, there is a couple of things that I need to do. So first of all, let me just quickly configure auto formatting, the code auto formatting and auto indentations with the extension that we installed at the beginning. I think it was this one, Clang-Format, right? Okay, this is quite simple. So what we need to do is to go to code, preferences, settings, and then type in the search box format. Then we need to switch to the workspace tab. And what we want to do is to change the default formatter to Clang format. So it's this one. And also we want to tick the format on save. Right, this is it. And now I can close the tab. That created a settings file in the VSCode directory. And essentially it enabled the feature to auto format my code. So when I save now, Command S, right, everything gets auto formatted. Cool. So that's the first thing that we need. The next one is, since at the beginning we want to send a request to the local server, we need that local server. So I'm gonna build it now with Golang, just the simplest one. So essentially, what I need is to go and create a folder here that I'm going to name local server, and inside the folder I'm gonna create main.go. To write Go code in Visual Studio Code, you need another extension. So if you go to extensions and type in Golang, it's this one, the Rich Go language support, Go 0.22.1. This is the extension that we need. I've already have it installed. Right. Okay, so the simplest web server in Go
what you need to do, say like package main. Then we need the main function, very similar to C, C++. And then we want to have just a function here that is handled when we go to the base endpoint, right? Which is just a slash. And let's just call it hello server. It's not really gonna return anything, but we need to have the response writer and request, and this is what's going to be called when the server. We don't need semicolons here. When the server, when the endpoint is hit, basically. Okay, and now also I'm going to read the body. So yeah, that's gonna be the IO util. Let me just save it. So it's going to auto import all the packages that are required. This is what the Golang extension does automatically for me. And what else I need is let's add some logging, right? So whenever the endpoint is hit, I would like to see the log with the information. So there's gonna be body and yeah, something like that. And also obviously we want to respond. We want to respond, and I'm just going to say hello from IoT server. I don't need semicolon. Cool. I think that should do. Oh yeah, the last line that I need is the actual listen line. So that's going to be http.listen and serve. That's going to be port 8080. Yes. So that should do. Okay. So let me just quickly start this server. I'm going to create a new terminal here. Cool. I need to go to this directory. So local server, and I'm just gonna say go run main.go. Just type in the console. Cool. So the server is running, and in order to check if this is working, just quick test locally. I'm going to just use curl to hit the server. Yeah, okay, that's the response we got. That seems like it's working. Let's see the logs. Yeah, there is a log. Nobody was on the request, which is correct. And just one more, which is it's going to be this one. Let's say we just sent some example data. Okay, we got hello from the server, and what we got, oh yeah, this is because what I need to do is to cast it to string, because we got byte, something I forgot. So yeah, let me just restart it, and going back to the first tab, curl again, and now we should see the right request body, which is correct. Okay. Right, so we got the server, we got the local server, we got auto formatting done, and the last thing that we need is to essentially get our local machine, the computer I have run this web server on. We need the local IP address of this computer, because our microcontroller is going to be connected to the same network, to the same Wi-Fi network. So, it will have access to the server that I've just created. And in order to do that, there is a simple command it can be used in the Linux as well as on the Mac environment. And this is ifconfig. So what I'm interested in here is this address, right? Which is I'm just gonna copy paste it here. It's gonna be useful. Yeah, so this is my local address. I can actually confirm this. I'm pretty sure if I just do again curl, but instead of localhost, I use this one. I should still get I should get the hello from server, which is what I got. Cool. So this is all done, and now finally I can switch to the C++ code. There's one additional step that I would like to do and this is making this code a little bit more abstract. It's just gonna be about renaming one variable, because like I would like this to be more generic, so not specific on the coffee making. Let's just call it a relay time, because this is about relay. It's not really about the coffee pressure coffee maker. It's more about relay itself. So renaming this to relay time, and instead of coffee ready time, let's just call it relay time. Cool. So this is done. Just quick check on with the compiler. Yeah, this is working. Great. So to implement sending HTTP request, first what we need to do is to locate the place where we want to send the request, and this is gonna happen right after the buzzer has been switched on. So this place. I'm just going to create it as another function. So let's create the function, a void function, maybe just right after switch off the buzzer, a void function send HTTP request. Just an empty function for now, and I'm going to call it here send HTTP request. Okay, just save the file. Great. So this is in the function body. We're going to implement the logic to send the request. Right. Instead of writing it completely from scratch, what I'm going to do is to make use of the examples from Arduino IDE. We haven't really installed this together. Let me just open it. Yeah, fresh. We haven't really installed it together. Link is in the description. Just follow the link and the instructions there. It's quite simple, quite easy to install Arduino IDE. So yeah, I'm not really going to do it in this video, because yeah, it's quite easy. All right, but yeah, let's assume we all got this installed already. What we need to do first is to go to menu, tools, and board, and this needs to be switched to the one I've actually got already, which is Node MCU 1.0 ESP12E module. It is really important, otherwise we won't see the right examples. All right, so that's what I've just made sure I've got this switched. I've got my Arduino IDE switched to Node MCU. And now, once I've got that, I'm going to menu file, examples. And as you can see, this section in the menu here, these are all the examples for ESP8266. The one I'm interested in is ESP8266 HTTP Client, basic HTTP client. That's the code I'm interested in. So that's gonna really speed up my development, because I've got everything almost ready. I need to do some copy pasting and need to move around some code. Okay, I'm going to paste it here. And what we're gonna start from is to check the includes. So Arduino we already have. these four we didn't have, so we want to include them as well. ESP8266 Wi-Fi multi. This is the class that we're going to use to connect with Wi-Fi. It is actually initiated here, put on the stack. So not new keywords, just like that. Then the setup function from the example. What we really care about at this point is we can do delay, right? Have some sort of separation at the beginning. And Wi-Fi mode, Wi-Fi stationary, I think. And the access points. Add access points. Okay, so these are the, I'm just gonna move those lines to my setup function. Cool. These let me just turn them into a constant, two constants actually. So we have define SSID. So that's my SSID. And the same thing is going to happen with password. My password. And yeah, I just need to remove the double quotes now. Cool. So now we've got the SSID. This is the name of Wi-Fi network and the password to this Wi-Fi network, to the local Wi-Fi network. Obviously, I'm not gonna show you what are my credentials, but this is where you need to put those credentials in order for the microcontroller to connect to Wi-Fi. Right. So, let's just assume these are my local network credentials. Cool. So we got that. This is essentially only setting up Wi-Fi. Doesn't connect yet. And another thing is Wi-Fi multi actually allows you to specify more access points. So if you have more Wi-Fis, you can just continue and add, another access point, and so on. And the way Wi-Fi multi works is it connects to the strongest Wi-Fi, right? In our case, we just want to have one Wi-Fi network here, and we really want to make sure it is the same Wi-Fi the computer with the Golang server is connected to. And this actually, this is what happens in my case. Cool. And for the sendHttpRequest, what I'm going to do is to move the whole thing, except for delay, to sendHttpRequest. However, two small modifications, actually one modification. There's gonna be more modifications, but let's start from modifying this bit, because since this is not in the loop anymore, we want to have a basic error handling, like, to handle the situation when it cannot really connect to Wi-Fi network. So what I'm going to do instead is to, let me just move this bracket here, and yeah, just save auto format. And this is gonna become a while loop instead. So we will have something like while this is not connected, we're just gonna try again. And before those attempts, we want to have a quick delay. So 1 second delay. And just for our information, we're going to print, send a dot to the serial port, right? So we'll see it on the screen. However, so, to still be able, hang on, this should be if it's not connected, right? Yeah. So if it's not connected, we're just gonna, have a blocking delay, blocking wait for 1 second, and then we're sending the dot. So we're gonna see the dots on the screen while this is connecting. However, we don't want for this to happen for the infinite amount of time, which might happen at the moment, because like, what if it cannot connect because, for example, you provided wrong credentials? We still want to have a basic error handling. For now, what we want to do is just, stop this while from happening after a certain number of attempts. So in order to do that, I'm going to define a variable. Let's call it failed attempts number, something like that. And then I'm going to add it to the condition of the while. So if ++ failed attempt number is greater or equal, it's less or equal to 10, then essentially we just want to continue, right? When it reaches 10, this is it, right? Regardless whether it connected or not, this is it. But right after that, we need to do the check if that was actually 10 attempts, right? So if we had 10 attempts, that means we haven't connected. There was something wrong. And this is the moment where we want to stop the execution of this function. And also, a good idea would be to, just for our information, to just, print out failed to connect to Wi-Fi. So that's what we're gonna get as a printout. Right. So that was for the error handling. You know what? Okay, yeah, we don't need actually the information that we connected successfully, because this is gonna be printed out right after. So that's fine. Okay, this is where we're going to need our IP address of the local server. So I'm just going to move that here. And we also need to specify the port. That needs to be exactly the same like the port here, 8080. And also what I'm gonna do is to change the method, HTTP method, to post in all of these places, because I would really like to send a message to the local server. Okay. Yeah, so let's just quickly go through line by line. So Wi-Fi client, it just creates instance of Wi-Fi client. This is required for this method. Then HTTP client is the actual HTTP client to make the request. HTTP begin establishes the connection, and that requires Wi-Fi clients to be able to connect, basically, to be able to do, I think, TCP connection. And then printing out post, then the method is set to post. That also requires a payload as a string. So let's just pass a payload here. I'm going to pass a JSON message, and let's just type hello from ESP8266. And this is something we should see in the logs, in the output of our Golang server. Then it checks what was the HTTP code that's been returned from the server. If the value is less than 0, then it just prints out an error. Otherwise, it checks for the status code. So it compares it with the HTTP code OK. So it checks if it was 200, right? Code OK is to 200, and then it reads the payload, the response body received from the server, and printing it out. Okay, and this is the method to end the entire request stream. Also, what we have is a message printed out if the connection cannot be established, right? So this is for this one, right? If that fails, we get this printed out, right? So now this is ready to be tested. However, before I do that, I need to change the time values so that I'm switching the relay time for 5 seconds, because 10 minutes is too much. Essentially, I don't want to wait 10 minutes. And for the buzzer, let's say 2 seconds. Okay, so now I'm going to deploy the code. Okay, the code is deployed. Let me just connect to the serial monitor. And also, I would like to see the output from the web server here. So what I'm gonna do is to stop the process here on this tab, on this window, essentially, terminal window. And I'm gonna go to task monitor and press here. This splits the terminal. So here I'm going to change directory to the local server and then run the local server here. So we can see all the output in here from the board and from the local server. Okay, let's switch to the board view and let's do the test. Okay, again, before I switch this on, I'm gonna make sure the 3v3 is not connected to the plus, which is not, right? We're just double checking. Okay, so I'm gonna switch this on, right? So you're gonna get the power supplied to the relay. And let's press the button and see what we get on the serial monitor. Switching on the relay off, buzzer, and HTTPRequest successful. We can actually see in a serial monitor and in the output from the local server that the request was successful. The body has been sent successfully. Yeah. And this is it for today. Tomorrow, I'm going to secure the request that we're sending. So I'm gonna change the HTTP protocol to HTTPS. We're gonna have to change the client as well to bare SSL client. And this is in order to be able to handle our internet hosted web service that we also need to create. And this is still gonna be Golang server, but it's going to be hosted on AWS. And I'm gonna deploy it using serverless framework. So yeah, stay with me. Tomorrow, gonna upload the next video. And if you don't want to miss that, hit the subscribe button. If you have any questions, you want to give me a feedback, or you have any suggestions for my future projects, leave the comment. Cheers, bye.